Hundreds of scientific talks, thousands of participants, and it's usually not free. So why are we here? Could this entire conference just have been an email? Let's find out. We are on our way to the conference of the German Physical Society. We have just arrived with the train to Linz, and in a few minutes we will catch the next train to Regensburg.
This guy.
The conference started with a workshop on AI in research.
You can think of this, and this quite naturally comes up the way we do this way.
Our values to this talk. And also we want a not
The ground being one feature, the sky and the buildings. And to build this, we have a different
And then followed the welcome evening, where we had to stand in line for over an hour to get food.
I'm a PhD student from the Karlsruhe Institute of Technology. I'm currently researching graphene superconductor hybrid structures.
How many times have you been to the DPG conference already?
This is my second time. Last time was in 2022. Corona was a little bit in the way.
Okay, I was also there. How many conferences do you go to per year?
Not that many. So this is my second conference overall. This summer I'm going to another one. Very much looking forward to all the preliminary talks and so on, making contacts. What I'm not looking that much forward to is all the very specialized talks with large intervals. I suppose it's a hurdle for many to enter them, as in to understand them if they attend, if they do not bring the exact prerequisite knowledge. And I think the main issue is that you're forcing people in a format of 10 minutes presentation, 5 minutes discussion, where they don't have time to explain any of the basics. So you cannot follow along if you're not exactly in that specialization. That's something that I think could be improved. Few less talks, or maybe distributed into smaller halls, twice as long.
We had a very nice lecture in the morning by Giesibel, which was actually quite inspiring. He was talking about his career. It was quite surprising that he had first been in industry and then he returned to academia. Also said a lot of interesting things about atomic force microscopy.
The frequency modulation technique uses an oscillator and measures the frequency change. So if there is an interaction between some atom and this tip atom, the frequency will change. If the forces are attractive, the frequency will go down. If the forces are repulsive, the frequency will go up.
Then I learned something new about embryonic development. There was even something about drug delivery systems, which is what I am working with. And right now is a break.
Rotating anti-clockwise all the time.
Okay, it's been a long day, but it's not over yet. The poster session is happening now, and in half an hour there's Einstein's lab. Let's go.
My name is Matthias Wader. I'm actually a physicist by degree and now research engineer by business card.
He's like the Joker of the microscopic world. And someone has to stop him. But what makes Trypanosoma brucei so dangerous? but at some point you get the good news, your paper has been accepted, you start to celebrate, the entire office is going to be drunk the next day, and then you take a look to your professor and your postdoc. And I hope that today I can add the next big thing in the space, which is going to be how to understand and improve your hydrogen sensor in 5 easy steps.
However, I'm living in a WG, in a shared flat, and you know that the concept of WG and order is a bit difficult.
I saw some biophysics and I went with Bensu to the job market and talked with some companies and were at a presentation about a company, so hopefully I will also find a job soon. After the poster session, I went downtown to meet with my colleagues where our professor had invited us for dinner, which was also very nice. Hey guys, it's Wednesday morning. Yesterday I had my poster session and it went quite well actually. People seemed to like the story I was telling, so that bodes well for the paper. So hopefully we will get that out soon. So now it is morning. It's important to get some exercise in when you are sitting in lectures all the time. So I brought my bike and I will bicycle a bit. And then there is the morning lecture at 8:30. It's a plenary talk, so hopefully it'll be interesting and understandable. Let's see.
And this can actually be also described using a thermal equilibrium analogy, where we fit the partition functions of F relation function and use an effective pair interaction to describe the stem cell interaction tissues. Now,
I thought that in academia, this kind of near misconception was, for example, when I went to industry and I wanted to make.
And then I'd like to thank my colleagues, my supervisor, to make a team, and our collaborators from München, PhysikTV, Matthias Billinger, from IBM, Leo Gross and Leonard Liske for fruitful discussions and funding. And thank you all for your attention.
Excited now. Actually, all you know the article that Grant published us in 2023 about the small thermal equation.
And we're really excited because, let me guess, so either you are already incorporating AI and machine learning in your research, or if not, you've been thinking about it, right? Now, scientists from all kinds of different fields, let's say, I don't know, cellular biophysics and quantum optics, start talking to and even collaborating with each other on AI because we're facing the same challenges and we have to learn from each other.
You can see here a schematic of the architecture of AlphaFold from the original paper. And AlphaFold starts from multiple sequence alignments. So when you use AlphaFold, you have to input just one sequence. But the first step that it does is that it searches for homologs in databases and uses then multiple sequence alignments of homologs.
And he's in charge of outreach and science communication in the CRC Sonderforschungsbereich 1242 at the University of Duisburg, Essen. Nicolas Herb is an established researcher in solid-state physics and plasma physics.
And here, the photon is going to be emitted, wherever when the electron is at the other side, it's going to be emitted there. Yeah? So now you've sort of entangled that.
Okay, it's Thursday evening and I'm honestly very tired. This morning we had some interesting sessions about AI that maybe I can use in my research. And then there was a lunch talk about science communication. I did want to go to some talks about softwares, but I felt a bit dizzy and opted for lunch break instead. And now I'm back because the post-deadline session is starting now. I hope I'll have energy. There's also a party afterwards. Let's see. Good morning, guys. It is the last day of the conference. Yesterday we had the post-deadline session and the party. It was really nice. The presenters were quite fun and the results were actually also very interesting. Hopefully they will soon be published. At the party we danced. I think we stayed until 11:30. One of my colleagues stayed even longer. I don't know when they left, but yeah, it was nice. This day, the last day, is a bit more calm. So I just have some talks that I'm going to at 11, and then there's a closing talk until 2, and then we're taking the train 3:30. So should be fun. Let's get to the university.
Overlay the document and so on, do whatever you want, do data analysis and so on. So that's the principal process. And it's important to really be very careful at each and every step.
What did you think of the party yesterday?
I didn't stay long, but I like the music. I think it was a great selection of music. Food was nice as well, but I was quite tired already. Like after 4 or 5 days of conference, I didn't have enough energy left.
Are you also a PhD student?
No, I'm a bachelor student. So I did my internship at the Nanojewelry Group. And I'm very thankful for that, since I was able to work at the solid liquid STM with gold. And I think it's a good idea to do like a project no matter where you are, if the group is like letting you, because it's a nice experience to get in touch with all the researchers and you get a bit of a feeling for yourself how to do research on your own. And I'm very thankful for that opportunity.
Is it your first conference?
No, it's my second conference. It's my first physics conference. So my first conference was a chemistry conference in Graz, which was very nice because Nobel laureate Ben Feringa was there, on whose motors I was working on. So it's nice to see the father of the things they're working on as well. But if I'm being honest, I actually prefer the DPG. The chemistry conference was nice, but I like the topics a lot more at this conference. So I kind of found the area what I want to continue on.
So are you coming back next year in Dresden?
I hope so, and I would like to present something as well, if it's possible. Most of the people are quite engaging and gave great tips. They really loved their subject, which was very nice. You felt the energy of the people. We also got a lecture at Yaroslav Gerasimenko. That was fantastic with Atosec and STM. The food is not so great, but I think the experience, like seeing all these researchers and getting in touch with them is, what do you say, immeasurable.
Okay, it's time to start. I'm very happy that many of you are still here and that you made it to this room for another highlight of the biological physics program. Welcome to the closing talk.
Is this B-roll?
Yeah, of course. So could this conference just have been an email? I certainly don't think so. But what do you think? Let me know in the comments and follow for more research stories.
You have to subscribe to How Research is Made on YouTube. There are a lot of new videos coming out, actually.
When you go to a conference, it's always good to send people back home a postcard, or maybe multiple postcards.